So in this video, I'm going to show you how I would create these different methods which can implement this additive secret sharing protocol. So the first thing that we want to be able to do was define an encrypt method. So we had a requirement for this where the encrypt method accepted a tuple, we're going to call it x, and then a number of shares that it should create. We're going to set that to be default to 3. Now, as you remember from the protocol, encryption is really about generating 3 shares such that when we sum them together and take a modulus of that sum, modulus, some large prime, that it will decrypt to the correct value, right? So the first thing we want to do, and I'll go ahead and do this outside of the actual method, is populate a list of shares, right? So this is an empty list where we're going to put our shares. And the first thing that I can do is actually, under the assumption that we were generating 3 shares, I can generate the first 2 shares totally randomly. And then it's just about figuring out what to set the third share value to so that their sum actually sums to the appropriate number, modulus q. Now, first thing we want to do is choose a really large q as well. So that would be a nice thing to have here. We can use this big number here. And then I go for I in range in share -1, shares.append random to randint 0 to q. And the idea here is that, again, the values of the first 2 shares don't matter, right? Because the only constraint that we have is that all 3 shares must sum to something. So once we have the first 2 shares, we can then use those to calculate what the third share should be. And for that, or the final share, is just going to be the sum of these shares, mod q, and then we're going to subtract this from q, which is the difference between when this wraps around, which is q, and sort of the sum of these values thus far. So this is the distance between when this would basically revert back to 0. And then we do plus x, plus whatever our value is. And I believe, let's set x to be 5 for now. Okay, and now shares append final share. And now we have our final shares. So now if I were to say sum these shares, mod q, we get out 5. Perfect, which is exactly what we were trying to do. So this is actually our encrypt method. Although I did say I wanted to return a tuple, so we can do a tuple, we can cast this to be a tuple. So now if I say encrypt number 5, I said in shares equals 10. Ooh, that didn't work. Aha, it's because we were setting this right here. Perfect. All right, so now we have the ability to encrypt a number using additive sharing. Okay, now let's work on our decrypt method. So decrypt method is just going to accept shares as input and then return the sum of these shares, mod q. Easy peasy. Now in some cases, in some languages you have to worry about, say, overflow issue here, where you need to actually mod q as you're summing up the shares, but in this particular case, q is not that large, so it's not too big of a deal. And Python's actually pretty good at managing really, really large numbers. It's got lots of convenience items under the hood. So now if I say decrypt, encrypt 5, boom, decrypts back to 5. Pretty cool. All right, and then the last method we need to do was an add. And for that, it accepts 2 different tuples. Now you remember that addition is really just about adding the corresponding shares together. So in this case, this is as simple as just iterating through each share and adding them together. So for I in range, length of A, I guess we could, assert len A equals len B, c.append, AI plus BI, mod Q, return tuple C. All right, so now if we said decrypt, add, encrypt 5, encrypt 10. Ooh, made a mistake. Oh, wrong bracket. It's supposed to be parentheses. Actually, I think we just have one too many. Boom. There we go. So now we can do encrypted addition between 2 numbers that are encrypted into multiple shares. Right? So I guess just to break this apart a bit more explicitly, so you can see what these look like, just so you know that they're definitely generating shares into the hood. Notice every time we do this, it actually generates a different set of shares because they're randomly generated. How about that? But they always decrypt to the same value. So I hope you've enjoyed this project, and in the next section, we're going to build on this and learn a bit more about the types of things we want to do with this encrypted computation. See you then.